So, hi everyone and welcome down at the NEC today, and we're down here at the environmental expo. So this got bigger this year, there's a lot more sections than we usually see, but I'm down here, I'm supporting both the BGA, and I also got a cryptic message from Tony at Leister Welwyn Tool. So I'm curious to what he wants. It was, will you be on the stand at 10 o'clock? So it's 9:30 now, so let's head on in and see if we can find Tony. So here we are at the NEC, and I'm joined by Tony. Hello, Tony.
Neil, how are you doing?
We're incognito here. We've had to hide. Now, some of you might have seen there's been a post up recently about a webinar that Leister are putting up for the new cordless heat gun system. Now, today, Tony has kindly brought the equipment along for me to see. So, I know many of you have asked about cordless machinery because we know the problems on site. You've got to run generators, you've got to keep power cords, etc, etc. So we've got the new machine here. Now I'm going to have to just flick the camera around. Tony, do you want to take the camera? So if you just point it down a little bit there. So hopefully, let's just see that we're all on. So we've got the Leister, and the official title of it is Next Heat 300. Next Heat. And I've never done an unboxing before, so we can see a little bit of literature here about the product. So we're fully battery operated. So here is the device. Again, we haven't got the battery in it at the moment, so this is all new to us. First of all, we can see there is obviously a nozzle attachment, which, they've given me a nozzle, which is always good. So we've got a nozzle in there. Again, what I'm going to do with this machine is have a look at it back at the yard workshop, and I'm going to put it through its paces. Yeah, so it's nice to see the machine, get a feel for it, the size of it, and also we've got the cordless unit that we're using as well. So some of you might be familiar with the regular Bosch unit, might be charging unit, and batteries that are going to be used. So that might cross over with other tooling that you're already used for your screwdrivers, reset saws, those kind of items. So got all the gear at home now. It was quite nice yesterday catching up with Tony and having a look at the new products here. So I've got the Leister, the new Next Heat 400, but also you've got the charging kit that comes, is going to be part of the package. How Leister packaged that's still being worked on. But one thing I wanted to look at first of all, and it might be the thought to you guys, is how do we power? How do we get our batteries charged? Now, traditional charging, like you most probably do with your drills and your recip saws, is through a normal 13 amp 240 plug. So we've got a little bit of a limitation. That's got to go into the site cabins where often there is a charging facility if they've got a 240 supply. Again, security issues about leaving your chargers, leaving your batteries. Now we know these units are going to be, batteries aren't the cheapest thing, but a lot of sites do have facilities to have your charging going on. One of the tests I'm going to run as part of this little video clip is to see what the longevity of one of these batteries is. Now I've looked at it, and this is the new Bosch system. This is the Procore drill battery sets, 18 volts, so they're high ampage as well, so they're good. These have got long life. I haven't tested it, but Tony quoted me around about 25 minutes on one of these, 20 to 25. Now obviously you buy the kit. This one's come in a box system with 2 batteries and the charging unit. Now the charging unit, as I said, is a 240 supply, but also they've got a new active air cooling system. So the fins on the battery are designed to cool it. It prolongs the life of the battery, improves the performance of the battery as well. So you do have different charging. There's 4 modes set for the charging to make it more economical, or faster charging, but obviously faster charging might deplete the function and the time run of the battery. So that was one thing that I wanted to consider. Also, we've got the heat in the off position there. So I'm going to look at, first of all, the on-off, and we've got the temperature. So we can turn the temperature up to a regular temperature that we would use here, and those that use the digital tracks would be familiar with the turn dial system. We're going to be looking at about, let's just say 380. There you go, 380. So we put that on, and we've got the initial run going on. So I'm not going to time this one, but purely by leaving it running, we're watching that arrow to see how long that takes. Hopefully that's visible. I haven't got too much backlight from the overhead lights. You can see the little arrow flashing there on the left. Just to give you an indication, the 5 bars at the bottom are how much airflow is going through. Now still, there we go. So the heat, according to the thermostat, is there. So we're at temperature. So it wasn't too long, I'd say less than a minute. I didn't time it physically, but the video will tell you that. Okay, so that's our time frame there. And if I just, there we go. We're just adjusting the heat. So we'll keep that in. There was a minor adjustment, so it's just reset itself. But if I let it go, I've stopped work, I'm doing something else, cutting a piece of membrane or getting something ready now. Obviously the air that's in there. And remember, I've not got a nozzle on this, so I'm just going to set a nozzle up when I work outside with it. But I'm going to fire it back up now. So we're back on again. So I've had that pause while I did other tasks. I've come to put the machine back on. I'm just using the timer actually on the camera there to see. So it was only about 6 or 7 seconds, and it told me that it was back up to temperature. So I've got a low battery on this at the moment. So we're down to 1 bar on the battery. So what I'm going to do, I'm running at 380, which again is a welding temperature that I might use. And we're going to see what it does as it gets towards the end of its heat and its power source, just to see how it comes to an end there. So we've just got a warning light come up flashing there, telling us that the power is low. Looks like a plug giving us just see it flashing in the top corner there. So we've got a warning light. Oh, it's a little heart. It's coming to the end of its days. So time to give one of them batteries a charge, as we've just done a few tests on it. So I thought let's put the stopwatch on. So we've got the charging unit here ready. That's dropped in there, so we've got an indication, and we can hear the fan on it. So I'm not going to do anything with the Eco Boost or the fast charge on it. I'm just charging it as it's come out the box. So we'll just keep the timer on there and see what that comes out at. So there we have it. It's just topped out. Let me stop the literally 51 minutes to get it to that point. So that was on a first early charge. So these batteries are brand new, and they went from being completely, this one went from being completely dead, which I always remember in the early days of batteries, they always told you to discharge them to get the cells to work better. So I'm just going to run a flat out time test today, just on with the new battery. So we're fully charged on the battery on the cell. We saw that the other day. So locking that in, ready to set a timer on this. So here we go. Let's start the timer, and we're off. I've got the settings at 400, so that would be a kind of common setting for me to run on. So just as we continue, we're only 5 minutes into the test. 2 minutes into the test. Clock's upside down to me. I am keeping the battery off of the surface rather than let it stay, because there are cooling fins which will assist with the keeping the battery in good order. Now this, as we're just approaching the 10-minute mark, I thought, well, first of all, we're never going to use this machine in such a long duration. To keep your finger on the trigger for this duration, I've actually changed hands roughly at 5 minutes, so it's not intended to do that kind of work. There's a little bit of warmth coming in the battery, and I thought, now we're at 10 minutes, let's just see where that battery is going. So that's down to 2 bars out of the 5. So we should be equating around about just under 20 minutes runtime. So I'm going to keep the test going, and we'll see what the duration of the overall duration is. So there you go. It's just taken, that was the final stages. It cut itself out at just on 19 minutes there. So that's it. The battery is kind of flashing on 1 bar, but there's very little. It's not enough to keep the battery going. So let's there you go. It's out at roughly just under 20 minutes, so 19 minutes. So what I wanted to do, looking at some of the workability, I know we've focused on the battery a lot so far, but really looking at the workability with the new machine, the battery powered, and with our traditional triax. Now I must emphasise I'm focusing really on what we would use it for in gas protection, ground gas membrane work. This is going to cross very differently for different sectors. Now I appreciate in workshop environments where it's clean and sterile, you're going to be the machine is going to be very well looked after, but that would be one of the longevities. How well will these handle being thrown around, dropped? Not that they deliberately do it, but accidents happen on site, we know that, and weather conditions that they're going to be exposed to. Okay. So continuing on, guys, Leister have now launched this officially. It's out in public domain, so speak to the guys about getting your hands on one of these if you're interested. Also, you know, I've been talking about that clip, getting the trigger to stay. 2 clicks and it stays there. So now, I didn't know how that worked previously. So what I'm going to do is just warm up our heat gun, and I'm going to go to the parameters that I was using previously. I haven't set it here. I haven't put a lock setting on it, so I'm going to run it up to about 400. Okay. So just so that it's getting familiar. Ready to weld. Okay, battery, good charge on that, fully charged. That's welding up nicely. There we go. Oh, it won't give you a reading while it's on. That's interesting because it's drawing power. So if I turn it off, it tells me there the power's there. Okay, so sharing the battery technology. Now I've mentioned this to quite a few verifiers in the past, and especially when we talk about vacuum box testing. Vacuum plates. Previously with Leister and Welwyn Tool, we did a little test with the mains powered one. Now some of you haven't seen that, but they've now brought out the new vacuum plate, which has got a battery compartment, so you can walk around your site quite happily now, have that strapped into your backpack or wherever you're going to work. But as we can see, when you get suspect areas of membrane problems, so this one's quite obvious, it looks like something's gone through the corner. Let's just run the test, and I think this is where the two items are going to work really well together, because if you pick up that there's a fault, and obviously I'm over egging it here, but soapy water, usual test, we cover the plate. Now hopefully the camera will see this. If you come right over the top, I'm just going to push the plate down. We can see the bubbles there, look at that. Quite obvious. And also we're not getting a full vacuum on the membrane. Yeah? So, we need to do a patch repair in there. So, what we're going to do, usual protocols. Let's give the membrane a clean. Because there was soapy water in there, I'm just going to also take a bit of cloth. Now, there's a couple of ways that we patch this. A common one that a lot of installers, certainly in the ground gas sector, will be using bitumen back products. Yes, I hear some installers say, oh, on hot days you don't need to do that. But I'm going to run it. I've set it to my welding temperature, and that's showing me that it's got to 400. The arrow stopped flashing, so we should be at 400. Not that that's critical for this bitumen work, but to bring that in there with my roller. So I'm just going to make sure we've got the heat application. So, patch repair on, because it's quite instant. Let's give it another test. Let's see if we're getting any bubbles come through. Okay, so back on with our vacuum plate. Again, keep your window clean. Okay, vacuum plate into position. And we've just got the thumb operation on this, so if I turn it so you can see it. Oh, there we go, nothing coming through on that. It's actually ballooned right up against the top of the sheet there. So we're not getting any draw through. Let me just do that again. Normally the ballooning of the membrane gives us the indication that there's a hole. Sorry, there isn't a hole because we're getting a solid vacuum inside the compartment, okay? And it's pulling the membrane there. So all we can see is the bubbles just running down. There's no bubbling on its own there, yeah? So that's why this piece of machinery is really useful to have the battery powered version, yeah? Those that will also, you might be welding patches over as well. So we're going to go back to our Next Heat. Oh, let's bring that on. Now I've got the knack of that double click. I'm just going to let that warm up. I'm going to prep my piece of membrane. Some of our landfill guys would be more familiar with possibly patching in smaller areas. So what I'm going to do, I've personally found I like the battery, the nozzle, the battery to be up and keep the weight in there. So what I'm going to do now, slow and steady. And with that trigger locked in there now, I don't really have to worry about, before on them previous tests I was having to keep that trigger engaged, but now I know that system. So that's held its temperature nicely. Let's just do a battery check. How much have we used? 1 bar out of our 5, so 20% battery usage there. Okay, I've got a little crease in that, but I'll tell you what, let's see what that does. Let's do our regular pick probe test. Sorry, mechanical stress point. I should use the official term. Yeah. So let's have a little look, see if we've got anything there. I do. Let's get that vacuum plate back into place. And again, how much battery is that drawn? None. Quite low usage on the vacuum plate, which is good. So let's just coat that up ready. Let's see how this performs now. Okay. There's no bubbles in there that I can see. And when we've got the condensation showing like we had there, let's just give that a wipe over. Just double check. See that section there. That's the bit I'm looking at there. There's no air pulling through there. Film a little bit here. These are just through there. So quite handy. Battery repair, job done. We haven't had to mess around with any leads or any generators, extra effort on site. So quite a compact setup to take to site and work with. Not that our verifiers will be using the heat gun to do the repair, but that's what this is there for, mainly repair work. So just using my presets that I've already talked about, I know that I like a temperature around about 405. It's given me the indication that it's already to temperature, so very quick in there. And I'm just heat using some regular LDPE, low density polyethylene membrane. Now the nozzle is thinner than what we would normally expect, but I just thought I'd give it a go. The hand welding position, actually the battery acts as a nice little rest to what I would usually use. So as we can see there, so provided the seam is consistent, can withstand the elements of 8485. So our usual testing there, see how it operates in the shear, but also in the peel environment. So really just confirming our tests, and we can see we've got delamination, so it's destroyed the membrane there. We can see fully the aluminium core, so you can see the kind of again, gas membrane specific here, but looking at some of the detailing, we've got to do a weld line across the top there. I think that's going to be quite feasible to do. So what I'm going to do is just center the camera off, hopefully, if I can just move that down. So again, we'll fire up on our handheld. I've been running it a little bit this morning, so within 6, 7, 8 seconds we're roughly there, which is great. So again, I've got a nice kind of angle. You can see the weld in position there. So test is done. It's welding down nicely in there on that position. So what I'm going to do at this point is get myself some self-adhesive ready to start detailing that corner. So this is where I would normally take my 300 standard 300 self-adhesive. So let's just get a piece of that cut off. Sorry about the wobbling there, folks. I'm doing this out in the Neil's yard. So normally we would take that first 300 and using, this is just bitumen backed polymer, bitumen backed self-adhesive membrane. So basically the core material. But what my first cut would be is to just to get some heat onto that to get it warmed up. So at this point, this is where I'm going to have to be heating. Again, doing this one-handed, because I'm not really reliant on specific heat here, but doing it one-handed, the good thing is I can actually what I want to do, as opposed to if I was using my triac with the heat, I would normally leave that and I can get my two hands on it in a position so the heat from the triac, once I've achieved what I wanted, I can go straight into the formation. Whereas with this machine, with the battery powered, yeah, we can still get the heat in there. We've just got to be a bit more planned and get used to the working operation, that the heat is applied to the back of the bitumen so that I can then get into my corner formation to where I want to form it. Now the next move would normally be, traditionally with the triac, I can use the heat on the surface to start completing the fuse of the bitumen, the self-adhesive. I haven't got power on this today, but normally my heat, so that would allow me to move. So let's just replicate what that would be in this formation. Yeah, we can do exactly the same. Apply that heat, apply some heat to the back, ready to form that top corner over. So that's very doable. Yeah. So the only, well, what I'm going to do is get the next section ready to form, which is going to be the internal. So we're going to look at how we get that internal in. I can take the brick away now, and let's see how that performs. So I've got my self-adhesive all formed, regular cutting, no heat required at this point. So hopefully now, with the heat gun, again, I'm back into a one-handed operation to get this warmed up. Now I always leave one half of backing on anyway, so individual's working method. Again, a wider nozzle here might be beneficial to spread that heat around, but it is heating the bitumen, and we are at a point now where we can locate it. We've got the initial tack on it to do its job, and then we can bring the heat in, and like I regularly do with the traditional triac and the 40mm nozzle, I can bring that in from behind. So I'm working that. I've got to change hands, but as I mentioned earlier, I'm not overcritical on the heat setting for this, so it's working quite well. That was going to be one of my concerns, is how accessible is it with the battery, because obviously you've got a very different shape to what the triacs are. So understanding Okay, this is, I've got to now go to a point where I need to turn this upside down because I need my heat down there. This is always a tight spot to get to, but it's heating it nicely, doing its work. So finally, I'll just go to the traditional top, and this is always the easiest one to access, if I can get the vacuum paper off. So again, prior heating, we can do this upside down. Would I use this machine all day for every operation? I would say, because of the length of welds that I can do when I'm doing the traditional jointing of the sheets, no, I'd stick with a triac for that. Because I've got constant power supply, I haven't got to worry about my battery. But if I was coming on site just to do some little spot repairs, it would work very well there. You know, just the odd 2, 3, 4 meters, just to patch up where people have possibly failed in a weld. But for the bulk work, ideally we'd be going with a 20 or one of the bigger machines. But for this, but also if I was just doing little base, little repairs, small sections, I would look at it. Again, great for doing little spot repairs, just point of works, quick little remedials. I think these would be great. But as I say, to do bulk work, we need to stick with I think the traditional triacs are the mainstay of our work. But again, it does work. We would be able to use that on pipe details as well. Again, if we had 20 pipes to do, I'm just going to check my battery. So my running time for this morning has used 2 cells. That was a full charge this morning when I started this little test. Okay, so we've had a nice play with not just the new Next Heat 300, but as we can see, useful doing those welding, just the small welding that we need to do. We're not looking at big massive areas. Stick with your triacs and your triac digital versions. This is really for repair work, and just highlighting how good, you know, using the batteries. Yeah, we've got about a 20-minute runtime that we've already worked out on that. I've not done any runtime tests on the vacuum plate, but this is a really useful tool, especially if they're, you know, you're out on site and verifying. Would a verifier want to run with both bits of kit? I know some verifiers out there do patch repairs just as a get out of jail card, but really, you know, this is a useful bit of kit. Batteries again, so definitely give the guys at Welwyn a shout on this, because all this kit is available. It's there for you. Get in quick, because I believe there might be limited first issues of these, so however many hundred they're going to bring in. But yeah, that's there. It works well. I've had a nice play with it, so I'll see you all again next time with some more toys to play with.